In this podcast episode, Lex Fridman welcomes a panel of experts to discuss the evolution of code editors, focusing on the integration of AI technologies like GitHub Copilot and Cursor. They explore the transformative impact of AI on the coding experience, the challenges of debugging and context management, and the future of programming as AI tools continue to advance. The conversation also delves into the potential of AI agents, synthetic data, and the implications of scaling laws in AI development. The podcast begins with a discussion on the fundamental purpose of code editors, which are sophisticated text editors specifically designed for programming languages. Unlike traditional word processors, code editors offer features tailored to the structured nature of code, such as syntax highlighting, error checking, and navigation through complex codebases. The hosts emphasize that the role of code editors is poised for significant evolution over the next decade, particularly with the integration of AI technologies. They highlight the importance of making coding enjoyable, noting that speed and efficiency contribute to a more engaging experience for developers. The conversation transitions to GitHub Copilot, an AI-powered code completion tool that has gained traction among developers. The hosts share their experiences transitioning from traditional editors like Vim to Visual Studio Code, VS Code, largely due to the introduction of Copilot. They describe Copilot as a transformative tool that enhances the coding experience by predicting and suggesting code snippets, akin to how a close friend might complete your sentences. While Copilot can occasionally make incorrect suggestions, the overall experience is often positive, allowing users to quickly iterate and refine the AI's output. The hosts delve into the origin story of Cursor, which emerged from the realization that existing code editors were not fully leveraging advancements in AI. They discuss the impact of scaling laws in AI, which suggests that larger models trained on more data yield better performance. The team recognized that as AI capabilities improved, the tools available for programmers needed to evolve as well. This realization led to the creation of Cursor as a fork of VS Code, enabling them to build a more flexible and powerful coding environment that could better integrate AI features. Cursor introduces a feature called Tab, which enhances the autocomplete functionality by predicting not just the next character, but entire code changes. The hosts explain that this feature aims to streamline the coding process by anticipating the user's next actions and allowing for rapid iterations. The Tab feature is designed to be intuitive, enabling users to navigate through code changes seamlessly. The team emphasizes the importance of low latency and efficient model training to ensure that the Tab feature operates quickly and effectively, thereby enhancing the overall coding experience. The discussion then shifts to the code Diff interface in Cursor, which visually represents changes made to the code. The hosts describe their iterative process in developing this feature, highlighting the challenges of presenting diffs in a way that is both informative and easy to understand. They aim to create a user-friendly experience that allows developers to review changes without feeling overwhelmed. The team envisions multiple types of diffs to cater to different editing scenarios, focusing on making the review process more efficient and less tedious. They also discuss the potential for AI to assist in identifying important changes within diffs, further enhancing the review experience. The podcast then explores various aspects of large language models, LLMs, and their applications in coding. The conversation highlights the nuances in evaluating LLMs for coding tasks, noting that no single model consistently outperforms others across all metrics, such as speed, code editing ability, and context processing. Sonnet is mentioned as a leading model, particularly in maintaining performance across various tasks. The speakers express concerns about the limitations of benchmarks, which often do not reflect the messy, context-dependent nature of real-world programming. Benchmarks tend to focus on well-specified problems, while actual coding often involves vague instructions and requires a deeper understanding of human intent. The discussion emphasizes the importance of qualitative assessments and human feedback in evaluating model performance, as public benchmarks can be contaminated and may not accurately represent a model's capabilities in practical scenarios. The comparison between ChatGPT and Claude reveals that both models have their strengths and weaknesses. Claude is noted for its reasoning capabilities, particularly in solving complex programming problems, but it may not grasp user intent as effectively as ChatGPT. The speakers discuss the challenges of training models on public benchmarks, which can lead to overfitting and may not generalize well to real-world coding tasks. They also touch on the technical aspects of model performance, including the impact of hardware differences on model output and the potential for bugs in the underlying systems. Prompt engineering is identified as a critical factor in maximizing the effectiveness of LLMs. The speakers discuss how different models respond to various prompts and the importance of crafting prompts that convey clear intent. They mention a system called Preempt, which helps optimize prompt design by prioritizing relevant information and managing context effectively. The conversation suggests that while users should feel free to express their queries naturally, there is value in being articulate about their needs to improve model responses. The idea of using structured prompts, akin to JSX in web development, is proposed as a way to enhance communication with the models, allowing for better context management and more accurate outputs. The potential of AI agents in programming is explored, with the speakers expressing excitement about their capabilities. They envision agents that can automate tedious tasks, such as bug fixing and feature implementation, thereby enhancing the programming experience. However, they also caution that agents are not yet fully capable of taking over all programming tasks, as much of programming involves iterative processes where human input is crucial. The discussion includes the idea of agents working in the background, potentially handling tasks like setting up development environments or managing pull requests, which could significantly streamline workflows. The concept of a shadow workspace is introduced, where AI agents can operate in the background to modify code and receive feedback from language servers without disrupting the user's workflow. This approach aims to allow the AI to learn and iterate on code changes while the user continues their work. The speakers discuss the technical challenges of implementing such a system, particularly in ensuring that the AI operates within the user's environment and mirrors their setup accurately. They highlight the potential for AI to run code and provide real-time feedback, which could lead to more efficient programming practices. Debugging is identified as a significant challenge for current LLMs, with the speakers noting that models often struggle to identify and suggest fixes for bugs. They discuss the idea of training models to introduce bugs intentionally, which could then be used to develop reverse models for bug detection. The conversation emphasizes the need for models to not only generate code but also verify its correctness, especially as AI takes on more programming responsibilities. The speakers express hope that future advancements will lead to better bug detection capabilities, allowing models to catch both trivial and complex bugs effectively. They also consider the implications of integrating a reward system for bug detection, where users could financially incentivize the model for finding and fixing bugs, although this raises concerns about the potential impact on user experience and the honor system in such a setup. The conversation touches on the implications of AI-generated code and the potential risks associated with it. There is a concern about the safety and reliability of code produced by AI models, especially when it comes to executing potentially harmful or dangerous code. The participants discuss the need for robust testing and verification mechanisms to ensure that the code generated by AI does not introduce vulnerabilities or unintended consequences. They emphasize the importance of maintaining a balance between leveraging AI for efficiency and ensuring that the code adheres to safety standards. The topic of branching in file systems is introduced, highlighting the idea that just as version control systems allow for branching in code, similar concepts could be applied to file systems. The discussion explores the potential benefits of implementing branching in file systems, such as enabling developers to test features against production data without affecting the main codebase. This could lead to more efficient workflows and safer testing environments. The technical complexities of implementing such a system are acknowledged, but the participants express optimism about the possibilities it could unlock for development processes. The conversation shifts to the challenges faced by startups and companies as they scale their systems to accommodate increasing user demands. The guests share their experiences with scaling their infrastructure, particularly in relation to caching and database management. They discuss the difficulties of predicting where systems might break as they grow, emphasizing that scaling introduces unique challenges that require careful planning and adaptation. The conversation highlights the importance of building resilient systems that can handle increased loads without compromising performance. The issue of context in programming is addressed, particularly in relation to how AI models can better understand and utilize context when generating code. The participants discuss the trade-offs involved in providing context to models, noting that while more context can improve accuracy, it can also slow down processing and increase costs. They express a desire to enhance automatic context retrieval systems to improve the user experience. The conversation also touches on the challenges of managing context in large code bases and the need for better retrieval mechanisms to ensure that relevant information is easily accessible. The discussion includes insights into OpenAI's O1 model and its implications for programming. The guests speculate on how this model could be integrated into existing tools and workflows, emphasizing the need for thoughtful implementation to maximize its benefits. They acknowledge that while the O1 model has potential, it is still in the early stages of development, and there is much to learn about how to effectively utilize it in practical applications. The conversation reflects a cautious optimism about the future of AI in programming, recognizing both the opportunities and challenges that lie ahead. The next topic revolves around the use of synthetic data in training AI models. The guests categorize synthetic data into three main types: distillation, where a model generates data for training a smaller model, generating data that is easier to produce than to verify, such as introducing bugs for bug detection, and generating data that can be easily verified, like mathematical proofs. They discuss the potential of synthetic data to enhance model training and improve performance, while also acknowledging the challenges of ensuring that the generated data is representative and useful. The conversation highlights the ongoing research in this area and the importance of finding effective verification methods to ensure the quality of synthetic data. The conversation continues with a comparison between reinforcement learning from human feedback, RLHF, and reinforcement learning from AI feedback, RLAIF. RLHF involves training AI models using feedback from human users, which can be subjective and may introduce biases based on individual preferences. In contrast, RLAIF aims to leverage feedback from other AI systems, potentially leading to more objective and consistent training outcomes. The guests discuss the implications of these approaches, noting that while RLHF can capture nuanced human preferences, it may also lead to overfitting to specific user behaviors. RLAIF, on the other hand, could allow for broader generalization across different tasks and contexts, but it raises questions about the quality and diversity of the AI-generated feedback. The guests express optimism about RLAIF's potential to enhance AI training, particularly in creating more robust and scalable models. The discussion shifts to the possibility of AI contributing to groundbreaking mathematical discoveries that could lead to a Fields Medal. The guests speculate on whether an AI could solve complex mathematical problems that have stumped human mathematicians, thus earning recognition in the mathematical community. They ponder the implications of such achievements, including the philosophical questions surrounding credit and authorship in mathematical discoveries made by AI. The conversation highlights the distinction between generating solutions and verifying them, drawing parallels to the P versus NP problem, where verifying a solution is often easier than generating one. The guests agree that if an AI were to achieve a significant mathematical breakthrough, it would challenge traditional notions of authorship and merit in academia. The topic of scaling laws in AI development is explored next. The guests discuss the original scaling laws proposed by OpenAI, which suggested that larger models trained on more data would yield better performance. They note that subsequent research, such as the Chinchilla paper, refined these laws by addressing issues related to learning rate schedules and optimal training strategies. The conversation emphasizes the importance of considering multiple dimensions beyond just model size and data quantity, such as inference compute and context length. The guests express excitement about the potential for new architectures and training methods that could optimize performance while managing resource constraints. They highlight the role of distillation in improving model efficiency, allowing smaller models to retain the capabilities of larger ones through effective training techniques. The final segment of the podcast focuses on the future of programming in light of advancements in AI. The guests envision a future where programmers have greater control and agency over their code, emphasizing speed and efficiency in the development process. They discuss the potential for AI tools to assist programmers by automating repetitive tasks, generating boilerplate code, and facilitating rapid iteration on design decisions. The guests express concern that relying solely on natural language interfaces for programming could lead to a loss of control and specificity, advocating for a hybrid approach that combines human intuition with AI assistance. They believe that the best programmers will continue to be those who are passionate about coding and who enjoy the creative aspects of software development. The conversation concludes with a sense of optimism about the evolving landscape of programming, suggesting that it will become more enjoyable and accessible as AI tools improve.